Here we are at lesson 9, so we're going to look at the continuous random variable still, but we're looking at expectation, variance, and percentiles. So as far as what we were doing last week, looking at discrete variables, the expectation and variance is going to look really similar. And then we will be taking a look at percentiles as well. So expectation and variability, so the expected value, similar to last week, we should still be considering as an average. And so we are going to be looking at the expected value of x if x is a continuous random variable. It's the average, or mu, mean. And we would have x times our PDF. And we would take the integral, you could say from negative infinity to positive infinity, or even just reduce that to the sample space of x. And I'll show you what I mean in an example. And then the variance, it's going to look very, very similar. The equation will be the same. It's going to be the expected value of x squared minus the expected value of x squared. Now, the only thing that's changing is we're not using a summation, we're using an integral. So the expected value of x squared, we're now going to have x squared times f of x. The standard deviation, if you've calculated the variance, is just going to be the square root of the variance. So square root of the variance will give you the standard deviation, which should be pretty similar. It's going to basically be nearly identical to the discrete case, except now we're not using summations, we're using integrals. Okay, so like I've said before, we have these habits of finding examples that we like, and we kind of just exhaust them. So we're still looking at propane, the propane example. So for a particular facility, we're looking at x is our random variable for the demand in propane in a week in thousands of gallons. And it's defined for being between 1 and 2. And just note that anywhere else, that probability is 0. So we don't observe demands under 1,000, and we don't observe demands above 2, or at least that's what we're assuming here. So if I want the average demand, so language-wise, if we say average, if we say expected value, we are looking for the expected value of x here. So expected value of x, and if I go from negative infinity to a positive infinity, x times f of x dx. And I think we all know, at least one calc teacher, that's going to totally flip out if you leave out that d of x. Just saying. I definitely had that teacher. So I'm going to go ahead and plug in. You might note that we don't need to go from negative infinity to positive infinity to see everything. We just need to go from 1 to 2. So x times 2, 1 minus x squared dx. So let me see here. I'm going to go ahead and one, 2x minus 2 over x dx. I'm going to get x squared minus 2 times log x. So a note that I want to talk about notation-wise, in statistics, when we write log x, we mean natural log x. So this is log base e. By default, though, in statistics, if we write log, unless we specify otherwise, it is natural log. Even to the point where if I wanted to know natural log of 5 in R, you would write log of 5. It is our default base for logarithms, so just keep that in mind. So just want to keep that there from 2 to 1. So I'll have a 4 minus 2 log 2 minus. So 1 squared is 1. Oops. 2 log 1. So I might go ahead and combine like terms. It's been a while, but log rule, so 4 minus 1, that's going to be 3. Let me see. I'm going to have 2 log 1 minus 2 log 2. So it's going to be log 1 squared plus 2 squared divided. I know my log rules. It just took me a second there. So I'm going to have 3 plus, this is natural log of 1/4. And that's going to be about 1.6137. And note, X is propane demand in 1,000 gallons. So on average, based on this distribution here, I could expect an average of 1.6137 thousand gallon demand in a week at this facility. So that's what this is getting at. There are other ways to get this. I've seen where folks will go ahead and use a U sub. Absolutely, that's doable. There's definitely more than one way to integrate this. So you didn't have to do it my way. Just keep that in mind. So now calculate the typical deviation away from the mean. It's asking for the standard deviation of X. It wants to know, hey, sort of on average, like how far do the demand values deviate from the mean. So here, that means we're actually going to calculate the variance of X first, and then we're going to square root it to get the standard deviation of X. So just remember the variance of X, it's going to be the expected value of X squared minus the expected value of X. So we just calculated this, and then that squared. So we're going to have to do a side quest again, find the expected value of X squared first. So for the sample space, so from 1 to 2, X squared times 2 times 1 minus 1 over X squared dx. I particularly like this one because you can tell right away things are going to cancel very nicely. So still from 1 to 2, you're going to have yourself a 2x squared minus 2 dx. So that's going to be 2x cubed over 3 minus 2x evaluated from 1 to 2. So that's just going to be, so 2 cubed is 8, so 2 times 8, 16 thirds, minus 2 times 2 is 4, minus 1 cubed is 1, so 2 times 1 is 2, it's 2 thirds, minus 2 times 1 is 2. So I end up getting what, 14 thirds minus 2, it's going to be what, 14 minus 6 thirds, 8 thirds. So remember, this was a side quest. That's the expected value of X squared. So that's not my answer, not yet. So we're close. So the variance of x is going to be equal to that expected value of x squared we just calculated minus the expected value of x that we calculated on the previous slide squared. So 8/3 minus that 1.6137 squared. And that's going to be about 0.0626. I recommend not doing rounding until the end, or at least being very cautious when I put this into a calculator or even R. I do it in a way that I'm not rounding at each step. You'll find in like, especially programs like WebAssign, if you round at each step here, it tends to compound rounding errors, and that's where you will have all of the work correct, but because of how you round it, it's just different enough from the answer to get marked wrong. Definitely worth avoiding. So things to note, I found the variance of x. I haven't quite answered my question, so almost though. Standard deviation, now I need to square root my variance. So square root that 0.0626 number, and I get something like 0.2502. And it's still in 1,000 gallons. So a typical deviation from the mean is going to be about 0.2502 thousand gallons. So that would be our standard deviation in this scenario. So then looking at percentiles, this is something that a lot of people use. I mean, in height and weight, especially anybody who's gone to the doctor, taken young children to the doctor, they talk about what height and weight percentile people are in all the time. Definitely any sort of standardized exam scores, SATs, GREs, pretty much whatever. The idea of a percentile is this percent is below whatever score or whatever value. So if I am in the 21st percentile on the English test, that means that my score is above 21% of people. But it does imply that 79% are above mine. So if I wanted, we're going to use that notation, x is p over 100 a lot of times. So if I wanted let's do 25th percentile. That's a common one. You would write it as x 0.25 or x 25 over 100, whichever is totally fine. Technically, these are quantiles, but they're the difference between percents and proportions. So we have a handful of them that are really, really common. The 50th percentile is one of them. We call this the median. So the median value has 50% of the observations below it and 50 above it. So it splits it perfectly in half. And so we would know, hey, whatever that 50th percentile value is, so this is going to be a value of x. That means that 50% are below it. And so we're going to go ahead, we're going to use this. We're going to take that propane example again, and we're going to calculate some percentiles with it. We'll talk about what we mean there. Okay, so we're going to look at an example here. Still the propane gas example, so I hope you like it. And so specifically, we're going to use the CDF that we calculated earlier, and we're going to calculate that value of x. So remember, x is between 1 and 2,000 gallons, that only 5% of weekly demands exceed. That sounds weird, and I want you to be cautious. So if only 5% exceed it, saying, hey, I want the top 5%. So I don't want the 5th percentile. If 5% are above it, that means 95% are below. I want the 95th percentile. So I want to know the value of x 0.95. That's what I want to calculate. So definitely be cautious. Depending on how things are worded, you want to make sure that you're calculating the correct percentile. Because if you calculate the 5th percentile, it'd be something down here. It would be much lower than the 95th percentile. So looking here, f of x 0.95, we know it's going to be between 1 and 2. So 2 times x 0.95 plus 2 over x 0.95 minus 4, and that's going to be equal to 0.95. So I'm setting it equal to the area that I want underneath, so that 0.95. So I do get to set that. So from here, you see, I go ahead. This is going to be really, really like, hopefully like algebra. It's going to be solving for x. We are going to need to use the quadratic formula, so bear with me here. I'm going to go ahead and subtract 0.95 from both sides. So plus 2x 0.95 minus 4.95 is equal to 0. So things to note, I know that this value of x has to be between 1 and 2. So if I multiply both sides by it, it's a positive number, it's not going to switch any signs, that's okay. And I know that it's not 0. So I'm going to multiply both sides by x 0.95. So I'm going to get 2x 0.95 plus 2 minus 4. This is squared. 4.95x 0.95 equals 0. Did I go from there? I think I divided by 2. So, I mean, you can say, okay, x 0.95 squared minus 4.95 divided by 2 times x plus 1 is equal to 0. This should look like you can use the quadratic formula. In fact, in this point, like, you're going to need to use the quadratic formula. So, because quite honestly, to do this by hand would be really, really difficult. So thank goodness for the quadratic formula. So a is 1. We'll see. I might run out of room here. A is 1. B is minus 4.95 over 2. And C is also 1. So if I want to solve for x, it's going to be equal to that. You see, minus B, so minus 4.95 over 2 plus B squared .95 over 2 squared. Sorry, I have difficulty talking and writing this at the same time and actually being useful. So minus 4 times A times C. Oops. Yeah, all over 2 times A, which is 1. And I'm going to get two possibilities here. Oops. I could get 0.509 or 1.966. So remember, x is in thousands of gallons, and this function's really only defined for, or at least what we're using, between 1 and 2. So it cannot be 0.5. It will be this value. So what this means is demands of 1.966 thousand gallons. See, 95% of the demands are below it, and only 5% are above it. So only 5% of the demands for propane at this facility are going to be above 1.966. So very, very few. And then because we're not quite done, we're going to also calculate the median. So remember, the median means we want the 50th percentile. So we want to know where half are below. So I don't know, I'm ballparking it. So we want to know where 0.5 or 0.50 are below. So we want x 0.5. It's also totally acceptable to say 50 over 100. So for this, it's going to be an extremely similar setup. So we're going to say, okay, well, f of whatever the value of the median, it's going to be, and we're just going to plug it in here. And I strongly recommend, this is a great place to pause and try this yourself, because absolutely you can watch me do the math. It is not the same as doing the math. Trust me. I've been there. I've just written what the teacher writes. It's not the same as writing it out myself and trying it first. So this time though, just know that we're going to set equal to 0.5, not 95, because we want the median. So all the steps are going to be identical to the last one, except this value is different. So going ahead, I'm going to have 2x.5 plus 2 over x.5 minus 4.5 equal to 0. I'm going to multiply both sides once again. So I know that the median, it's between 1 and 2, so multiplying both sides by it, it doesn't have any effect on any signs. That's good to know. It's not equal to 0. So x.5, and heck, I'm also going to throw in a divided by 2, just get rid of those 2's there. So I'm going to get x.5 squared plus 1 minus 2.25x.5, and that is equal to 0. So A is going to be 1, B is going to be negative 2.25, C is going to be 1. I'm going to need to use that quadratic formula again. So x.5, according to the quadratic formula, right, because it's that minus b plus b squared minus 4ac, right, throwback, hopefully, 2a. It's not one of those things, oh my gosh, you have to have this memorized, but this is something that is useful to, like, if you can look it up and use it. It is still important to know how to do this. So I'll have, what, 2.25 plus 2.25 squared. I'm kind of taking into account the minus signs cancel out there. 4 times 1 times 1 all over 2 times 1. Oops. So just going to clear some space here. So because it's a quadratic formula, I can get up to 2 values here. I could get 0.6096 or 1.6404. And so this is that time where you have to go ahead and look at it and say, does it make sense that 50% or below 0.6096 thousand gallons? Considering that we haven't seen any demand that low, no, it's not going to be. So what this actually, see, I try to doodle. It's going to be more like 1.64. Obviously, I can't draw to scale. I'm not going to become a designer anytime soon. So what this is saying is, hey, for, you know, a weekly demand of propane of 1.6404 thousand gallons, 50% of all of the other demands are below it. 50 would be above it. So that would be my median. So medians are really, really popular. That's 50%. You also we'll end up talking about the first quartile and the third quartile. So quarters like 25th percentile and 75th percentile. That'll be something we get to. We're going to talk about it more, I want to say, in week 3. So yeah, that is lesson 9, and we'll get on to lesson 10 in just a few.